Welcome to Khetz Tutorials, and in this video, the second part of patterns, sequences, and series, I will be talking about series. So a sequence, as I previously discussed in the previous video, consists of numbers which follow a certain pattern which you can identify, either arithmetic, quadratic, geometric, or whatever the case may be. So you just basically have a sequence of numbers to whatever, so to the nth term, right? Whatever number of terms you want to have in your sequence. So we're now introducing series, which is essentially the same thing, but now we are interested in the sum of the terms. So if you're asked to find for this series, which you have over here, let's say you only had this 3 terms, and you're asked to find the series, which is denoted, or the sum, which is denoted as follows, Sn instead of Tn for the sequence. To find the sum of the nth term, which is the third term in this case, so let's say that the sum of the third term would be the sum of all of these that precede this third term, that is. So this is what we're saying. In a series, we are interested in the sum to the nth term. So you're going to add these up. This is 4 added to that is basically, so 5 added to that is 9. So the sum to the third term of this series is 9. So that is basically what we're interested in. And in the same way, we also have arithmetic and geometric series, right? Just like we had arithmetic and geometric sequences. So you basically apply the same principles, but now we're interested in the sum, and therefore we expect a change in the formulas as well. So for an arithmetic series, to find the sum to the nth term, right? These are, so I basically have 2 equations for each of these variations. So for an arithmetic series, you expect to have this as your formula, and you use this formula if you know the last term of the series. So the last term is known, last term is known. So basically substitute. So in this case, let's go along as we do. Let's do examples as we go along. Basically, so you have 1 plus 3 plus 5, and you're asked to find the sum to the third term of this series. So basically, you'd say n is equal to 3 because you're asked to find the sum to the third term. So 3 will be substituted there where you see n, and here this a still stays. So n is the nth term, and a is your first term of the series. So a is still the first term, as we saw when we were dealing with sequences. So a is the first term, and you basically have the first term as 1 in this case for the series, so 1, and here you substitute your last term. So you also find the sum to the third term, and we know that the third term is 5. So basically just substitute 5 here, and let's see. Previously, we just added this using our head or a calculator, whatever you basically used. So 1 plus 3 is 4 plus 5 is basically 9. So expect this to come out of this formula because we know the last term and we're asked to find the sum to the third term. So this is 6. So this is 6. So 1 plus 5 inside the brackets is 6. And you're going to divide. That is going to be 3. 3 multiplied by 3 is 9, which is what we're actually expecting. And those are actually the same things, right? So this formula, let me just clear everything up. I was just showing you how to use this formula. So let me clear everything up. So I write the formula again. Here's one of the formulas to find the sum to the nth term. So this formula you basically use when you have the last term. So you use this formula if you have the last term of the series. So you'd be asked to find the sum to n, given maybe the last term, or given the series if you have it. And the second equation associated with an arithmetic series, you have Sn is equals to n divided by 2 multiplied by 2a plus n minus 1 d, right? And this is if you don't know the last term. So if you don't know last term. So let's say we are given this series again. So let's do an example with this same series, given this series. And what will be the next term? It will be 7, then the next one will be 9. Right. And we know that the next term over here will be 11, right? But we are not given. So 1, 2, 3, 4, 5. So this is basically 1, 3, 5, 7, 9. So we know that this next term is 11. So we aren't given in the question. So let's not use the next one. Let's use. So for this one, it's quite tricky because you can simply compute the term number, or you can simply compute the term if you have this kind of series. So let's take a number which is definitely far away from 9, and for that number we shouldn't be sure of its position. So let's pick a number. Let me see, what can I use? So a number which is in the series, but that same number we shouldn't know which term number it is. That doesn't make sense, because we need our n in this particular sequence to actually do that. So let's say we are asked to find right. So let's say we don't know the last term in the series, and we're just asked to find the sum of, so this is the second part. So let's say we don't know the last term, and we're asked to find the sum to 8 terms, basically. So you're just basically going to substitute 8 wherever you see n. And this a is the 1, because the first installment of this first term in your series is 1. And here you're going to have 8 because you have n in that position. Subtract 1. And the difference, or the constant difference across all of these, is 2. And you're just basically going to compute the sum to 8 terms. And here you have 7 multiplied by 2, which is 14, added to 2, 16. So this is what you basically have over here. And the answer should be 64. So that is basically how you use the second formula of the arithmetic series. So finding the sum to n terms using the arithmetic series, you have this first formula, just a recap, which you use if you know the last term. So this is just a simple formula which you use. And the second formula is over here. And this is if you don't know the last term of your series and you want to find the sum to n terms, right? Now we move on to geometric series. You also have 2 formulas over here. And the first formula goes like this: r to the n, and then you're going to subtract 1 divided by r subtract 1. And you use this particular formula if r is greater than 1. And this r is your ratio, which you're going to find by either dividing term 2 by term 1 or dividing term 3 by term 2, or if the ratio is actually given in the question. So you use this formula if r is greater than 1. Now the second formula, which says Sn is equal to a, 1 subtract r to the n divided by 1 subtract r. You use this formula if r is less than 1. So if r is less than 1, you basically use the second formula. If r is greater than 1, you use the first formula. And the same principle still applies. You just basically substitute. So here you'd be explicitly asked, let's say, to find the sum to whatever term. So you basically substitute the number of term where you see n, and you substitute the first term of your series over here, and you can actually compute the sum. So the use or the usage of each of these formulas, whether geometric or arithmetic, is basically the same, but you just have different formulas for each of the type of series which you have. That is basically it. So once again, this is for r greater than 1, and this is for r less than 1. Now, here's a final note which you have to know with regards to series. There's a formula here which says Tn is equal to Sn subtract Sn minus 1. And this is what this means. So I'll go back to a geometric sequence which I looked at in my previous video, which was 2, 6, 18. Just to explain this. This says to find the term at a certain point n, and n corresponds to the number of term. You basically can do that if you're given a formula for the sum. So let's say you have a formula for the sum to n terms. So you find the sum at n terms, and you subtract the sum of the previous number of, so let me just do this to explain this. So let's say we want to find the sum to 3 terms. So Sn, so S3 subtract S, so n minus 1 will be 2, will give us this value over here. This is what this means. So to find the third term, you subtract the sum to the second term from the sum to the third term. That is how you basically find your 18. And let's verify if this is true. So you basically have 2 plus 6 plus 8. So this is your sum to 3 terms is 2 plus 6, which is 8. And added to that would be 26. Right? And your 2 plus that would be 8. So now, saying S3 subtract S2 would give you a value of 18. So this formula says, if you want to find the nth term given the formula for the sum to the nth term, you can basically find the sum at the term which you're looking for and subtract the sum to the term which occurs before the term that you're actually looking for. So you're going to compute to find Tn, whatever number n is, you're going to find the sum of to n, and then you're going to find the sum to n minus 1. That is basically what I was showing you here. And that is the final note with regards to series. The next part of this first topic will be about sigma notation as well as infinite geometric sequence. So if you like this video, just go ahead and give it a thumbs up. If you haven't subscribed, please subscribe.